Hello there, once again. This is Al, still sick as a dog, and prepared to move on to part 2. In this batch file mini tutorial, which doesn't really have to do with the batch script that I want to make, but just some methods that you may not be aware of that you can use, or that you never realized that you actually had, even though you didn't know it, the ability to use such things. Now, I don't have anything running here. Well, I got all these things running, but they're not visible. This screenshot, by the way, is something I'm quite proud of. The original doesn't look quite as nice as this. I made some improvements. But anyway, Anchor. Now, first, let me go back to this derives thing. I already deleted it. I can make it again. No? We need to do a standard IO and direct for directory. Car Now, what we had before, I can change that slightly. I might want to, but let me just go to the first example. The condition here, we wanted to print out available drive. So let's change drive to I. It comes out to error. Then the drive is available, and I had a put car here. But actually, what I didn't really want to put car. What I really want is I want a carriage return. Well, let's see the character. And then the character. Oops. Uppercase character. Otherwise, print nothing. Right? Okay. Let's try that again. Oh. Took CL out of my path. It's a utility that I don't always use. Okay. CL error. Name in car RP. Oops, that'll do it. I hate the way this thing works now. That's usually what my drives program would do. And the reason why you want the carriage returns is so that you don't have to extract a letter out of that string, like get out the first letter. Nowadays that's easy, but in the old days you couldn't take just one letter out of a string. So typically what I would do is fix my drives thing so that it cannot do what it just did, or it can just print one letter. Let's say I might have a Boolean variable, print only one lecture equals false. Now I could say if RC is 2, so that means the parameter arg1, and what I want is arg. I'm thinking about a switch. Let's say that's a slash character. Then that means there's a switch. So the switch would be the value of the switch would be the next character. And if there is a next character, I could say if the second character is equal to only one letter. Let's say I could use a number for a number to print out the maximum number. But let's keep things simple. O for 1, S for single. So it's little s or big S. In that case, I want my thing to be true. Okay. Now if that's the case, then I should break out of this loop when that's true. Right? I printed 1 and I break. Okay, true. Well, is there no such thing in C? It's good enough. Okay, no more trues and falses. And really, I should put the 1 on this side to avoid an accidental assignment. These ones are safe because those things are constant. I think that's okay. You know what I hate about this? Okay, almost there. S undeclared. S. That's true. There's no quotations. Alright. So as before, there's that. If I put a slash, now with an S, I only get 1. Right? Now it's strange, but no, that's correct. Really, I don't need the, now in this case, I don't need the carriage return. Right? But anyway, it's there, and we can deal with that. Now with a facility like this, making the anchor program is not too hard. There's the subs command, right, which works this way. If we knew of an available drive letter, all we got to do is somehow get the output from this into this section and put a colon after it. In fact, we could make a program like insert the colon, and then we need the path that we want to use, and the current path is always given by %cd. These are capital letters. See, that's always the current path. Let's see. Make it big and long. See? Okay, so we have %cd to get a path that we want to assign the drive letter to, and we can get the first available drive letter. It's not what I want exactly, but it's pretty close. So let's see what we can do given what we have. I'm going to batch file. Now I have my anchor. I'm going to call this Z anchor. Z anchor. EV means that for me to just types in this bit for me where I want to go, the name of the file, and adds the extension if I need it. Okay, now we got our drives, and it prints out letters. Now, how can we now use that output in another command? Well, one way is to use for. Everything uses for. If I did /f drives /s, right? That's a command. And what /f does is it treats the output of a command as though it were the output of lines coming from a file. And we use the single quotes for that. So that means that %i will contain that letter. So I'm going to call something. Something with a nice name. Okay. And we always need these to make sure we don't walk into ourselves. Okay. So now we have a drive letter. We just need to use the subs command. Sub. And the way the command works is that you say drive letter, which is %1 : that's our first available drive, and then the path that we want to associate with it, which is that. I don't think that quotations are required, and then we should be done. That should do it. Now at the end of the day, if we just type subs here, that'll give us a listing of the current substituted drive. So let's see. First, let's put this in my utility again. Delete it from here. Go somewhere else. ANCHOR. Okay. So it worked. The first available drive was, let's watch it in action. Get rid of that one. Get rid of that control off. So I'm going to run the program. Let's see what happens. So first set local. Now then it runs command, do something with %i. So that amounted to call something with the letter A. When we got into something, we said sub, and we added a colon, and then we gave a directory. And then we returned, and there's no more output because we specified only one output. Okay, now what happens if we run it again? We should get B. Oops. We'll go to a different directory. And it did work. See? There, call something, and now I call something called with the letter B. And I did subs B, my current directory, which is that. And so it seems to be working. The only question is, what about spaces? What about this? Will it work here? Let's see now. Incorrect number of parameters. You see, it didn't work in that case. So what we're going to do is we're going to put quotations around the current directory. That's easy enough to do. Now what has gone wrong? A, B, E is supposed to be a variable. I don't know why E was good. Let's get rid of B just to be sure. Okay, it does work. It does work with B. So the problem is the E was not available, even though my program did not have a problem with changing to drive E. Well, what's on drive E? Device is not ready. Okay, so now there's a problem. Well, let's see. I don't know if my thing works properly with that letter either. Let me see if it does. No, it did work. My thing refused E and F and G and set me at H. So even though our program was written in C and everything, using that magic function succeeded with the A and the B, it wasn't able to determine this fact, something I hadn't showed you before. That listing is not complete, or one of those listings is incomplete. Both of them are incomplete in a sense. Now how do I see computer? You see, there are these drives, E, F, and G. I don't know what they're doing there because I don't have any. I do have a DVD drive. I don't, as far as I know, I don't have a removable disk in the app. And I certainly don't have two DVD drives. I don't know why it says this. But they are listed and they are installed drive letters, even though they're not valid at the moment. I suppose they could be in the future, and they're reserved. So the drives program is not good in that it's listing drives that are it failed to change to, but failing to change to a drive doesn't necessarily make it available. Alright. Okay. So now I would like to get rid of all these. H. A and B. Okay. K and L I always have. Alright, so what will work? Well, a lot of trial and error goes into this sort of thing. And what I did was I resorted to one of my usual things to resort to. It's called int jump int something. Now we're going back to the Intel land, and I knew that I know there's something called change drive, and I figured it must have something to do with DOS. And DOS is interrupt 21. And I searched for drive. Okay. Now select default drive. I tried this one. Okay. A, B, C, and so on. But the problem with this one is that if you try to select, let's see, what's it supposed to do? No, it's not those. Anyway, you call int 21 with E, and you select a letter, so starting at 0 for A and so on. But what happens is if you hit one of those drives that are potentially valid but not available, then a great big message comes up that asks you, like, abort, retry, fail. And I was happy about that. But I noticed that there are these other ones, so I tried this one, 19. Get current default drive. Well, I certainly don't want that. So I checked this one, 3B, set current directory. Now this seems like the right one. Now let's see. If we do that and we pass a path name, right, to become the current directory, carry file clear successful, AX, YZ, etc. However, this one too, I believe, had the same problem. This is the same. This is that changed exactly that changed one that we used with the program, and you saw that didn't work. That failed. Well, it succeeded in saying that we couldn't change to a certain drive, but it failed in the sense that it didn't tell us that the letter was reserved. So now maybe this is what I look at next. Let's go back to here. I can tell which one it was by the history. There's an old thing in DOS, something called a file control block. Here, I ran into this somehow, and this turns out to be the one that works. Now, Nobody uses file control blocks anymore or anything, right? This is a throwback to an ancient time when it still wasn't clear what sort of data structures would be used to represent files. Okay. However, the Windows operating system is very backwardly compatible. In fact, it's so backwardly compatible. It's still probably compatible with PCM, its precursor, CP/M, the precursor to DOS. CP/M? I think it's called CP/M. Oh, I don't know how to search for it. Google. The precursor to DOS was CP/M. Yeah. See? File system and so on. Now, in fact, DOS itself is just basically a straight up copy of CP/M written by someone else with the addition of these files. A file system. CP/M didn't have a file system, really, and that's why DOS was called DOS. Like, the OS part refers to operating system, and the D refers to disk. Disks were a great new thing coming out, so they took CP/M, stole it, and added support for the new disks coming out. And so Windows kept maintaining support for compatibility with CP/M program. I'll show you something you probably have seen before and never understood why. D for me is shorthand for debug. And I get tired of typing. This now means dump. Okay. There we go. You see that there? That is a hallmark of CP/M. And what that is the 2-byte command sequence that causes a program to terminate. You will notice that it is at position 0 in memory after I typed debug. Okay, I'll type debug. Okay. That translates to an instruction called int20, which is the 2-byte instruction for terminating a program in CP/M land. CP/M only had things called command files. That's where the .com comes from. If you make a program that's a .com program, you can give a name. Well, I can give a name inside here. Small. That'll be the name of my program. Okay. Now, my current position in memory is 100, not 0, right? The stack pointer always, doesn't matter, at least for COM program. For a command program, the stack pointer wherever it points to or whatever it points at is initially pointing at the value, a word value 0. Okay. So if I give as my first instruction in my program the ret instruction, which is C3, okay, that's going to take me to wherever the stack pointer points to, which is 0. I'll trace through that, and now I'm sitting at a terminate program instruction. Now the reason why that had to work is because cp/m command programs terminate themselves by calling the return function, the return command. Execute a return, and that returns control back to the operating system. This is may not have been cp/m, but return has certainly taken us to a place which, if we run through this, our program terminates. So in one byte you can write a whole program. Now, so turns out it still supports file control blocks too. And the command then has been good ever since DOS 1.0. In 21, function 29, AL, parsing options, see table such and so. Parsing options. I don't know. I don't even care. I don't even think I used it. This is supposed to be a table, but it's not. It didn't come out very well. Skip separators. Use existing drive letter in file control block if no. Use existing file name in file control block, etc. What are we supposed to pass in? What we're supposed to pass in is a file name and a pointer to a file control block, which is a region of memory. Now, what's going to happen is the file name passed in can be a string. It can have wildcards, and the DOS will parse that string and build us a file control block. Great. I don't even know what a file control block means. I don't even know how they work. What I care about is this fact that after it returns, the AL register contains a result code, and if it happens to be FF, that means that an invalid drive specifier was passed in for the file name. Okay? And I don't care about the rest. If I get an FF back, that means that drive's available, right? And as you saw, it works even for these ones were not considered invalid drive specifiers. These letters, those were valid. H was the next one, which was said, according to this function, was an invalid drive specifier. So this works better than change the other method. Alright. So how hard can it be? All we gotta do is call this function. So let's make the program. Let's make a program that does it. Okay, first thing we need a file name, which has to be pointed at by SI. Well, let's enter in over at 200 a file name. Now, it doesn't matter what I use for the drive letter, but I'll start out with an A, and then I just need a file name, right? It doesn't matter. It can have wildcards, it can have anything. So, a file. Now, this is DOS, so the chances are that the terminating character is going to be a $, but it might not be. So, but we can put a 0 there at the end. So here's our thing here, a file, and that there definitely is a $, and that's already 0. Okay. So now that's 100 bytes away from where we started. Actually, how about we put it on line 190 and not 90, 1 FD. Same thing. Just to keep things below 200. Alright. Yeah, forget about the stuff here. Alright, get rid of the rest. Alright, now our programs, we should be able to fit our entire program before we run into our string. And we're going to keep the $, here and a 0. One or the other is going to terminate the file. The string, I should say. Okay, so all we're going to do is put into a high 29. Now, DI, SI has to be the point to the string. One F0. Okay. And then we gotta call it 21. Now we're starting with the letter A. Now, either it's going to succeed, in which case we got to keep searching, right? Or it's going to fail, in which case we're done and we want to print out the letter, this letter. Otherwise, we'd like to increment that letter. So, first we need to compare A low with F. And if those are equal, we're done. I don't know where to go. We'll figure that out later. Otherwise, now we need to compare SI with Z. If we tried Z, then we're done, right? We could use a counter up to 26, but we can still compare. Just compare. It's a byte value. If that's equal to Z, which believe me is 5B, Now, if that's true, then we didn't get anything. So if that's true, we just want to quit. Now, the fail case, this is success. So wherever this goes is success. Otherwise, we want to jump back to, we want to increment this volume. So what we'd like to do is, if this is true, we want to go somewhere. Don't know where. Otherwise, we want to increment the same thing. So that we change this from an A to a B, and so on, and then jump to 100. Alright, now I can sort out the rest of this. In the case where, well, let's deal with the failure. We hit Z. Let's let that go to 114. We'll have a, no, let's deal with this one first. If this is a FF, invalid driver specified, that's good. And whatever the letter is, here is the one we want to print out. We want to print out just that first character. So this one, we'll let it jump to 114. Okay. How do we print it out? That's easy. Well, let's make it a call. We'll have a function that prints whatever is that SI, one character. Okay. And we'll put our function at, I don't know, 140. We'll fix that up later. And then we want to terminate. So now 109 ought to go to 114. Okay, 114, which calls the print function and quits. And this one, 10B, should jump to 117. No, sorry. It's the result of the comparison 10E. Right? Jump if it's equal to that to 117. Don't get so far. Now if this fails, 114, print and quit. If we hit a Z, go to 117, just quit. Alright, now we need at 140, we need our printing program, our printing routine. Well, it doesn't have to be that far away. How about 120? That's better. Now, this is an easy one. Move into A92. Move into below SI D low and A high 2 and D low is a character value, which will be a letter, drive letter. Int 21 will print that to standard out, and then we return. Okay. Now it's a bit messed up because 120 doesn't match. How do I make it look better? That way we can see. These don't do anything. Okay, so now that returns. So the call happens, then it returns, and it ends up on the quit line, which quits. Prints the character, then quits. Now, our string is at, what was it? 140, I think. Is really far away. 1 0. So I don't think we need to go that far away. But we put it at 130. I can move from okay, so there it is. And now it looks all messed up again. I can put in no ops. Okay, so you can see at 130 there's a string. And that's a 0. 138. This is 137. This is 138. And this position is 139. And this is 13A. Well, back here. No, it's not. It's 13. No, isn't it? Oh no, I was right. This position is 138. So that means our whole program is 38 bytes big. BX all clear. Did I give it a name? I didn't. Next. Okay. So now I have a program called nexters.com. So I call it? No, what if I coincidence that can't be? 3, is that 80? No, What's 58? Should be 58. Oh, here it is. Okay. Next, DRV. Oh, I said M next. Actually, I'm Alright, there's our program. Well, is it going to work? Let's debug it. So here we are. Okay. Oh, now see, now I know the bug already. Because the source is no longer there. It's where we put it at 130. Sure, it's 130. Yeah. And there's the 0. Okay, SI is 130. Now I'm going to print, proceed with int 21. Now you notice I got an FF. That means fail. So A is available for the theory. And that comparison is made. It is a true comparison. Takes us to 114, which is going to call our print function. And let's trace through A high 2, D low, 5C, 5C. I think SI is 130. I'm going to refresh SI. That's the problem. SI got bumped up. I see. I see. This this thing alters SI. Yeah. See. First unparsed cat. Okay. Alright, then we need to fix our program. We need to do, we got space to move things around. We can refresh that here. So, how much does it cost to move something into SI? 3 bytes. So move these down to 3. Up to 126. Okay, so now at 103, even though you can't tell, is our function still there? Okay, so that refreshed it. Now that might be a problem, but I don't think so. That's a fixed number for us. Write out these new changes. Something weird happened. It's got a new box. Okay. You see how you have to go through these things. Calling 21. We got the FF. Great news. It's true. We go to 114. It calls our print function, which refreshes SI to 130. Puts a time 2. D-low goes into D-low goes 41. Prints out a letter A. Returns and quits. So it looked like it was working. I paused. Okay. Didn't have to pause long. We forgot to set up DI. We need to point this somewhere to receive the thing that we don't even care about. That's why I didn't put anything for it. Okay. Now that's going to have to happen here. SI is 130. We can let the file control block go to 500 or something. So we need to move. How much does it cost for this? Move into DI 500. It's a 3-byte command. So we're going to move all these down 3. $102 to $118 inclusive to 102 plus 3 is 5. 500 is a good number. Everything else the same. Yeah. Understand, you gotta understand DOS. When a program, when DOS gives control over to a program, that program owns all memory to the end. So we're allowed to, we can point this thing anywhere we want. We own all memory starting from our program onwards. Okay, so it's going to store the unstorable at 500. Right up the new version. Since this is half day. Better work this time. 500, 130. Sounds good. 170 again. Is 117 the right one? Oh, it is. Those are relatives. Except 123 is not correct anymore. We'll write it while we're here. We're still on that line. AX241, print the letter A, return, and it works. All right. How much time have I used? Well, this will be part 2. Now you've seen that we have a method of determining the next drive using the debug program. Now I'm going to combine what we know about debug and what we know about batch files in order to do this, all of this magic from our batch file, and optionally set the drive, starting the drive letter. Okay, see you.